student. We analyzed and trained several deep learning models on deepfake dataset and compared them. So I would like to start with the problem definition. What is a deepfake? It's basically modifying a target image, like some image, by using another source image and altering the target image. The most popular usage of it is altering the human face image, changing the face of someone. And this gets more realistic as the AI and deep learning improves. So, and creates a society, it creates a threat to the society. And what kind of threats it creates is it's alternating inappropriate videos to use to blackmails. This is especially target women, and it's getting a bigger threat. Also, making public figures say things that they have never said or they wouldn't say. There are already, and after this information spread on the social media or some other video medium, this can be late to prevent it, even if it's detected. So there are some popular examples like that. This is the Gabon's president, Ali Bongo. He was absent, and in order to lay down the doubts about him, they released a fake video. He's doing a speech, and it caused, it backfired. And then another one is that comedian Jordan Peele talks and imitates Barack Obama and says things that Barack Obama will never say. This video intended to warn the use of deepfakes. And our goal in this work is to get one of the latest data sets on this topic and try to detect or identify the fake and the real videos from each other. You see some examples on the right. So this data set from Facebook AI, it released last year, end of the last year. It has more than 120,000 videos of the 960 unique paid actors. This makes this data set unique too because the actors had the consent about the use of the videos. And as seen from the example, it has very wide variety of age, gender, and ethnicity in the dataset, which makes it very hard to detect and process. Also, the angles, illumination, and environment was challenging. They used several methods like modified deepfake autoencoder to generate these fake videos, frame-based morphable mask. Another way is the neural talking heads. And then some popular generative adversarial networks like FSGAN and StyleGAN, but they modified it. Another dataset we tested is called Celeb Deepfake version 2. This is we used it only for testing purpose. This is where we tested learning or generalization ability of the compared models. And this data set contains 890 real interview videos that collected from YouTube of the celebrities, and more than 5,000 of them, and more than 5,000 of the generated fake videos. So they used custom encoder-decoder model to generate fake videos. So I would like to draw your attention here. So the first, the left column is the real image, real actors, and then the remaining part is the fake. If you give attention to, for example, this image and this image, you will see that the source and the target is completely different. It's modified and changed. We compared, this is actually an ongoing work, and I'm going to present extended results than the paper. So we compared a residual network, 50-layer residual network with a skip connection. This is the traditional network and the most popular one. MobileNet v3 is the optimized for mobile devices originally. It used hardware-aware network architecture search and net adapt algorithm. We use this model especially to see how the model it performs on small models like this one. And the dense net, the main idea is here, it's dense convolution network, and it connects all input layers to the output layers, so creating a dense network. An exception model is the extreme version of the inception model. The main difference is the order of the operations and non-linearity. We also compared inception v4 and inception ResNet v2. These are the similar models, only the difference is one of them has the skip connections. And finally, we compared efficient models, recent efficient models from the Google. They simply scaled their models by using a compound function, so that input resolution, width, and depth of the model scaled up proportionally. And this is the number of the models, parameters in the models. So as you see, some of them quite big, like 54 million parameters, which takes a lot of time to train. But we showed that, later I will discuss it too, that it's not necessary to have that big model to solve this problem. So what we did is, we first needed to extract faces from the videos, because videos are too big. They were in full HD resolution, and we only interested in the faces. So first we separated real videos, since they are less, and then detected faces on these videos by adding 30 pixel padding around face and keeping the larger faces. Then we did manual cleaning and did sampling. So we don't need all the faces in a video. We need some of them to classify a video. And by using the coordinates, we extracted faces from fake videos, since they were originated from the real ones. We followed similar pipeline for the test, but we changed some part. We used tracking here. We tracked faces, and if a face tracked successfully for 50 consecutive frames, then we sampled that once. This is because we wanted to eliminate false positives and only focus on the main target in the video. We applied this on the test set and then celeb DF datasets. Next step was the augmentation to increase the diversity of the dataset. So instead of using the raw image that inside the dataset, which is the top left one, we added some fake compression, noise, blur, sharpening, flipping, brightness change, saturation change, gray, and shift, scale, rotate. These augmentation methods chained, and they used with certain probability to chain. So more than one of them could be used, or none of them could be used. And finally, we used coarse dropout or cutout and grid dropout. These were supposed hard augmentations. So we only added one of them to the end of the default chain with, again, 50% probability. And we trained with fixed learning rate and Adam optimizer. So half precision is important here because it's proposed by NVIDIA, and it uses left memory on the GPU.
Sir, you have
all the images. Oh.
Sir, you have a 2 minutes to conclude, please.
Sorry?
Sir, you have 2 minutes to conclude.
Could you please repeat?
Sir, I have said you have 2 minutes to conclude.
Yeah, okay. I am keeping track of the time. And then I will finally talk about results. As I said, we averaged 50 frames per video, and then find the optimal threshold using ROC-AUK method, and then reported video-based results, since the dataset only has the videos. And because the celeb other data set was imbalanced, we did class-based reporting. Here we show that not necessarily big model needed, and then efficient models result better than the other ones. And here are the results for the celebration dataset, celebrities dataset. Yeah, we showed that efficient net models is better, and using harder augmentation may improve result, but not necessarily needed. Deeper and bigger problem models doesn't solve this case. This work can be improved with better face detection and sampling, more training and more tuning, and using different kind of final averaging. So yeah, just in time. Thanks you, everyone.
Thank you very much, sir, for your very interesting presentation.